All right, here is the second part of elimination in solving systems of linear equations. Here you're actually going to have to use step 1 where you multiply either the top or bottom equation by a number. So here we have two equations. Negative 6x plus 5y equals 25. And we have negative 2x minus 4y equals 14. This is where you need to know your multiples and what's going to work best for you. So the first thing is we need to look at our x's or our y's and see if we can either make the x's have the same coefficient or if we can make the y's the same coefficient with the least amount of work. There are lots of different ways you can do this problem, but again, we're looking for the least amount of work. And after we do step 1 where we multiply the top or bottom equation, you then need to make the decision, are you going to add or subtract the two equations? So if we look at the x's, I have a negative 6 and a negative 2. So is there any way for me to make those the same? Yes, I can multiply the bottom by 3, and 3 times 2 gives me 6. So they're exactly the same. If we look at the y's, how do I make those the same? So what is their common multiple? Well, 5 and 4, the least common multiple they have is 20. So I would need to multiply the top by 4, and I would need to multiply the bottom by 5 to get 20. That's more work than what I did for the x's. So we're going to go back and work with the x's. So like I said, the least common multiple for the x's is 6. So all I need to do is multiply the bottom equation by 3. Well, if I multiply just one item by 3, remember I have to keep my equation balanced, so I need to multiply everything by 3. So 3 times a negative 2x gives me negative 6x. 3 times a negative 4y gives me negative 12y. And then 3 times 14 gives me 42. Okay, now that I have that equation, I'm going to put my top equation on top just so that I have everything lined up the way that I want. Okay. So that's the only new part from the first set of examples. Now you need to decide, am I going to add or subtract the two equations to get 0 for one of my variables? Well, how do I make negative 6 and negative 6 disappear? Well, if I add them, negative 6 plus negative 6 gives me negative 12. So I actually want to subtract the two equations to make them disappear. Negative 6 minus a negative 6. Keep change gives me 0. So we get 5 minus a negative 12, and you get 17y. Then I get 25 minus 42, and that gives me a negative 17. So again, if you're a little bit confused, now would be the time to stop and rewind, or stop and pause and take a moment to look at the work that I just did. So I want to solve for y now. So what I can do is divide by 17. I get y equals negative 1. Looking for the intersection point of the two lines, so I need to find the x value as well. So when looking at these equations, they both don't look that great, so you need to choose the top or the bottom to work with. In this case, there's less negatives in the top equation, so I'm going to use that one to work with. So I have negative 6x plus 5y equals 25. That negative 1 is going to go in for y. Apologize for that. Okay. So when I simplify after plugging in negative 1, I get negative 6x minus 5 equals 25. 5 times a negative 1 is negative 5. So I can add 5 to both sides. I get negative 6x equals 30. How do I solve for x? I divide by negative 6. So x equals negative 5. Again, you would take this equation or this answer and you would take it and plug it back into your originals to make sure that it works for the top and the bottom equation, because again, you're looking for the intersection point. So the intersection point has to work in both equations. Here is the second example on your notes. It's 3x plus y equals 11, and I have 6x plus 3y equals 24. So what you want to do is find the common multiples for your x's or your y's. There are multiple ways to do this. You can look at multiplying by a negative number. You can work with multiplying by a positive number. It does not matter. So what I'm going to do is I'm going to show you what you would do if you multiply by a negative number this time, just so that you know it's an option. I could multiply by a positive. It's totally fine. It's just the way you solve the problem's going to be used. You're going to use subtraction. So if I look at my x's, what's the common multiple? The common multiple is 6. So I could multiply the top by 2. If I look at my y's, what's the common multiple of 1 and 3? I could multiply by 3 on the top to get a common multiple. Since I want to work with smaller numbers, I'm going to multiply the x's by 2. Now, you could multiply by a positive 2, which is totally fine. But I'm going to show you what would happen if you multiply by a negative 2. So I'm going to multiply the top by negative 2, if it's going to let me here. So negative 2. So you're going to need to distribute that negative 2 to all 3 of your numbers on the inside. So negative 2 times 3x is negative 6x. Negative 2 times y is a negative 2y. Negative 2 times 11 is negative 22. So now that I have redone that equation, I'm going to rewrite the bottom equation so that my information lines up. So now looking at this, you should notice that I have a positive and negative 6x. So that tells me that I'm allowed to add my equations. A negative plus a positive 6 gives me 0. So I can finish solving this. Negative 2y plus 3y gives me y. Negative 22 plus 24 equals 2. That worked out nicely. There's not a lot of work to finish just solving for my first variable. I'm solving for the intersection point, so I need to find the x value. So you have to go back to one of your original equations. The top one is smaller and has less work, so I'm going to work with that one. So I have 3x plus y equals 11. You're going to take that y and plug it in. So 3x plus 2 equals 11. Subtract 2, you get 3x equals 9. divide by 3, you get x equals 3. Again, to make sure that everything is accurate and correct, you want to take your intersection point 3, 2 and plug it back into your original equations. Plug it into both of them to make sure that everything is correct. Looking at this example, I'm not going to do the entire problem because I'm going to have the notes posted. But again, you want to look at your x's and your y's and see what the least common multiple is. For your x's, your least common multiple is 4. So you'd only need to multiply the bottom equation. If you look at your y's, your least common multiple would be 10. So you would have to multiply the top equation by 2 and the bottom equation by 5, which is more work. So I highly suggest multiplying the bottom by 4 and distribute that through. You could multiply by a -4 as well. Does not matter. You just need to make that decision on your own. Lastly, you have this example. The biggest thing here is you should notice that your x's and your constants are not lined up. Your y's are lined up on this side, which is totally fine. So before you start this problem, I would rewrite everything so that you have your information lined up. So now you need to make the decision, am I going to work with my y's or am I going to work with my x's? For your y's, the least common multiple is 5. So you can multiply by the bottom by +5 or -5. If you wanted to work with the x's, again, your least common multiple is 10. So you'd actually have to manipulate both equations, which is more work. So that's why I suggest working with the 5 or -5. Again, go back to my notes and use that to help you determine what to do next.